Let's begin with the lecture. What we are going to see is the other method of sequential search method. So up till now, what we have done is we have started with the sequential search methods, and we have completed the two methods. Right, the first method was the dichotomous search method. Um the next method is the Fibonacci method that we have completed yesterday, and today we are going to see in this lecture the golden ratio method, right? So the notes of those dichotomous and Fibonacci search method are already there on, I've uploaded on your Google Classroom, and I've also uploaded the answers to the homework, right? So please check your answers, and if there is any doubt as such, please check whether you have made any calculation mistake, and if it is not a calculation mistake and you do not understand, I'll be there to help you. But no, prior to that, check your answers, and no, no, because of that, you'll be understanding how the numerical is being structured, right? If you compare the dichotomous and the Fibonacci method, what is the difference in the dichotomous and the Fibonacci search method? It is just the approach of selecting the points, right? It is nothing different, right? Ultimately, we have to find out no, the x1, x2 values, and then the functional values of those particular variables. But how to place x1, x2 is different in the dichotomous search method, and it is different in the Fibonacci method, right? Even now in the golden ratio method that we are going to see, we are going to use this particular Fibonacci method as a background, and we are going to develop a new concept on the basis of the the previous knowledge that we have of the Fibonacci, right? So I'm just during the numerical solving part, I will be explaining you, but creating a background of golden ratio method, right? A golden ratio method. So now what we are going to do is, now we are going to do some assumptions. Let limit of n raised to infinity of fn upon fn minus 1 is equal to r. Also limit of n tends to infinity fn minus 1 upon fn minus 2, we are going to say it as r. Limit of n tends to infinity fn minus 2 upon fn minus 3, we are going to say it as r, and so on. So all this assumption that we have made, and now we also have, according to our Fibonacci method, we have a formula. Fn is equal to fn minus 1 plus fn minus 2. Yesterday we have seen this no, formula for the uh, making of the Fibonacci series. So dividing both sides by fn minus 1, what we will be getting is fn upon fn minus 1 is equal to 1 plus fn minus 2 upon fn minus 1, right? So now we are going to take the limits of it. Limit n tends to infinity fn upon fn minus 1 is equal to 1 plus limit of n tends to infinity fn minus 2 upon fn minus 1, right? So now limit no n rest n tends to infinity fn upon fn minus 1 is nothing but r. Here it is 1, and there it is nothing but 1 by r, right? So no, multiplying no all both sides by r, what we'll be getting is r square is equal to r plus 1. What we can write is r square is equal to, no, r square minus r minus 1 is equal to 0, right? Now if I have to find out the roots of this equation, the normal formula that we use is what? Minus b plus minus under root of 4 minus ac upon twice of a. So if I use this similar formula for finding out the root, what I'll be getting? R is equal to 1 plus root 5 upon 2, and the other no, it will be r is equal to 1 minus root 5 divided by 2. So now the r value here will be getting as minus sorry, 1.6180, and R here will be getting us minus 0.618. Now this value is called as the golden ratio. It is not visible here. I'll be writing here. It is called as the golden ratio. R is equal to 1.6180 is called as the golden ratio, and here R is called as conjugate golden ratio. Conjugate golden ratio. And now we are going to use this golden ratio, that is the value of R, that is 1.6180, to place the our experiments, that is to select the position of x1 x2 or the position of the variables in the different iterations, the various iterations that we need to do. Now this this is not a new technology, right? R is equal to 1.6180 is this golden ratio has been used by many of the mathematicians for many of the work. For example, this golden ratio tends back to particularly was invented way back by Egyptian mathematicians, right? And for the construction of the pyramids also, they have used this particular golden ratio. Even the theater skins that you go, when you go to see a movie, the movie is the dimension of the movie, or even your television is it is selected in such a way that it particularly tends to be one for the ratio of your length to breadth tends to be 1.6180. So that is also there are a lot of applications of this golden ratio that is coming out here and there, but this golden ratio has been not it is not a recent invention. The mathematician has used this golden ratio somewhere starting in the construction of the pyramids and all those particular. And now also when we select the dimensions of our monitor screens, or particularly the movie screens, so though at that particular juncture also they use this golden ratio. Now here we have the application of the golden ratio will be done in selection of the placement of our experiments, right? So placements of the variables in the iteration. So how we are going to do this is now now we have if you see the formula, previously हम लोगों ने एक formula फिबोनाची मेथड में देखा था, I0 star is equal to fn minus 2 upon fn into I0. तो ये मैं थोड़ा सा अलग तरह से लिखता हूँ, राइट? अभी ये वाला सेम टर्मिनोलॉजी नहीं होगा, तो ये फिबोनाची का है, तो आई वांट टू यूज डिफरेंट टर्मिनोलॉजी इन फॉर फिबोनाची एंड द गोल्डन रेशियो मेथड, सो दैट यू डोंट गेट कंफ्यूज. तो I0 स्टार को हम लोग बोलेंगे L0 स्टार. फॉर्मूला वही है, इज इक्वल टू fn माइनस 2 अपॉन fn, और ये इसको बोलेंगे हम लोग L0. मीनिंग सेम ही है, पर इसको बस हम लोगों ने दी वे ऑफ राइट दी वे ऑफ यूजिंग द सिंबल दैट वी हैव यूज इट इन दी डिफरेंट मैनर. सो दिस इज योर गोल्डन रेशियो मेथड का फॉर्मूला. ऐसा हम लोग यहाँ पे ये करते हैं, ठीक है? तो ये अभी हम लोग नो व्हाट वी कैन डू, वी कैन अप्लाई द लिमिट्स हियर आल्सो. so limit of L0 star and tends to infinity can be given as limit of fn minus 2 upon fn minus 1 and tends to infinity into fn minus 1 upon fn into L0. तो ये fn माइनस वन fn माइनस वन कैंसिल हो सकता है, पर ये ऊपर के इक्वेशन को हम लोगों ने fn माइनस वन के टर्म्स में यहाँ पे लिखा है. अभी क्यों लिखा है वो आपको समझ में जाएगा. सो दिस विल बी L0 स्टार, राइट? Limit of n tends to infinity fn minus 2 upon fn minus 1 is what it is, 1 by r, right? Into limit of n tends to infinity fn minus 1 upon fn is again 1 by r into L0. So what we get is L0 star is equal to 1 by r square into L0. So now what is going to happen is that we are going to use this L0 star for selection of the placements, right? For the selection of the dimensions, right? So even I can particular write L1 star is equal to 1 upon r cube into L0 for the next iteration. I can write L2 star is equal to 1 upon R raised to 4 into L0, right? So the formula is very easy to remember basically. Again, L3 star is equal to 1 upon R5 into L0. Now what is happening that these are the formula. This is your first iteration. We are going to place our experiments with respect to L0 star. In our second iteration, what we are doing to do is we are going to place our experiments with respect to this value, that is L1 star. In our third iteration, we are going to place our experiments with respect to this L2 star, L3 star for our fourth experiments, fourth iteration, and likewise, right? So I'm hoping that you have understood what we have seen up till now. What is important here is that in each of this formula, L0 is common. No, don't make it as no, L1 star is equal to 1 upon R cube into L1. This is not the right formula, right? In every step it is with respect to L0 only, that is to be remembered, right? Otherwise what is going to happen, in Fibonacci method it is somewhat different, right? In Fibonacci method, if we go and find out I1 star, we use the formula, in the formula we use I1, right? But here it is not the case, so I've made it, I've used the symbols only different, so that you don't need to you don't have to get confused in this two Fibonacci method and this particular method, right? So I'm hoping that you won't be creating a confusion. Then we'll be seeing the numerical, you will be getting that it is it is very very simple than the Fibonacci method, right? Because what is the magic here? We don't have to remember the Fibonacci numbers, and here we don't have to remember the Fibonacci methods. So the chances of getting the chances of using the wrong Fibonacci number in the iteration get cancelled, and the chances of getting wrong answer will also get reduced, right? So what we'll be taking, we'll be taking a normal example where we'll have to minimize fx is equal to 4x cube plus x square minus 7x plus 14 within interval 0 comma 1 using golden ratio method, or it is also called as the golden section method, right? Doesn't matter. Now how this is going to start, right? So here what we have initially is fx, it is 4x cube plus x square minus 7x plus 14, and the interval given, right? The interval given is what it is, 0 comma 1. So what will be the value of L0? Therefore L0 is equal to 1 minus 0 is equal to 1. Now let's start with our first iteration. In first iteration, what we are going to use our formula? Our formula will be L1 star, right? It will be 1 upon R square into L0, right? So now what we can do is we can find out the value of L1 star. L1 star is equal to 1 upon, what is R? R is your golden ratio. It is 1.618 square into 1. If you do find out this value, it comes out to be 0.3819, right? Now what we are going to do is we are going to consider 0 1. So this completely is our L0, and this is nothing but your L1 star. This is our x1, this is our x2. Now can we find out x1? X1 is equal to 0 plus L1 star, that is 0.3819. So it comes out to be 0.3819. and x2 is equal to 1 minus 0.3819 is equal to the value will come out to be 0.6181. So I urge, I request you all, to solve this numerical again at your home and check out all these values are right or not, and accordingly you'll be also understanding the equation, right? So here we have to find out what is the value of fx1. Fx1 can be given as 4 into, instead of x we'll have to substitute the value of x1, right? Plus 0.3819 square minus 7 into 0.3819 plus 14. The value of fx1 comes out to be, according to my calculation, 11.6953. Similarly, I'll have to find out the fx2 value. 4 into 0.6181 cube plus 0.6181 square minus 7 into 0.6181 plus 14, and according to me the value comes out to be 10.9999, right? Now the problem is a minimization problem. If we represent fx1 here can be represented on the higher side and fx2 on the lower side. So this is 11.6953 and it is 10.9999. What is this problem? It is a minimization problem. Here what we can write is fx1 is greater than your fx2. So if fx1 is greater than fx2, which region we can eliminate? Therefore, eliminate region left of x1, right? Therefore, new interval that we are going to get, new interval. What is the new interval here? It is x1 क्या है आपका 0.3819 comma 1 is our new interval, right? And next iteration we have to do in this interval. I'm hoping that you are getting this, right? So let's do our second iteration, right? Second iteration. In second iteration, our new interval is 0.3819 comma 1, right? So now we have to find out what is the value of L2 star. L2 star can be given as 1 upon R cube into L0. This is important. 1 upon 1.681, sorry, 681 cube into 1. So if you find out this value, it comes out to be 0.2361, right? So here we have our interval, that is 0.3819 and this is 1, right? So here it is our x3 and x4. This is L2 star and again this is L2 star, right? So value of x3, it will be 0.3819 plus 0.2361 and the value of x4 will be 1 minus 0.2361. So if you find out this value, 0.3819 plus 0.23 x1 comes out to be 0.6181 and here it comes out to be 0.7639, right? Similarly, you can find out the values of fx3 and fx4. I won't be writing all the equation here again. I'll be just writing what is the value of fx3 and fx4 coming out to be according to my calculation. So here it comes out to be 10.9999 and for 0.7639 it comes to be 11.0193. So if we represent it, so here it is on the higher side and here it is on the lower side. So 10.9999 and it is 11.0193. So here what is there? F of x3 is less than f of x4. Hence, eliminate. Which region will have to eliminate? It is a minimization problem. Hence, eliminate the region right of x4, right? Therefore, new interval that we are going to get, therefore new interval what we are going to get is, what is the new interval? 0.3819 comma, what is the value of x4? X4 is 0.7639. So this is the new interval that we are going to get, right? So now what we need to do is, again, the functional values are not coming to be same, right? But normally what is to be done, even if in the numerical, the number of iteration, many of the numericals, the number of iterations will be given. But if the number of iterations is not given, you have to at least go to the fourth iteration. If in second or third iteration your value is coming out to be same, the functional values are coming out to be same, that is, these two values are coming out to be same, then you can stop. But even after doing the fourth iteration, you are not going to get those values similar, then you will be stopping at the fourth iteration. Don't go for fifth iteration, sixth iteration, because the numerical may have, it may take 10 iterations or 11 iterations, but in examinations we, in examination we have restricted time. So it is, I tell you that go for only fourth iteration. uh, Before fourth iteration, if the values of the functional functions are coming out to be same, stop at that particular juncture only. If till fourth iteration, if the values are not coming same, you can end your numerical at fourth iteration only. So if it is, now we are into second iteration, we'll have to do our third and fourth iteration as well. Let's continue with our numerical, and let's see if before fourth iteration the value comes, the functional values are say coming same or not, right? So for third iteration, we already have found out the new interval. I'll be writing the new interval here. So the new interval that we have is 0.3819 comma 0.7639. Right now we are into our third iterations. Here we can write here L3 star is equal to 1 upon r raised to 4 into L0. So it is 1 upon 1.618 raised to 4 into 1. If you do the calculation, the value comes out to be 0.1459, right? So now, drawing this graphical representation of our interval, this is 0.3819, this is 0.7639. Here it is third iteration, right? So here we have x5 and x6, right? So this is our L3 star and this is our L3 star, right? So x5 will be equal to what? 0.3819 plus 0.1459. So the value comes out to be 0.5278. For x6, the value comes out to be 0.7639 minus 0.1459. It comes out to be 0.6181. You can calculate the functional values f of x5 and f of x6. I'll be telling. F of x5 comes out to be, according to my calculation, comes out to be 11.1721, and according to calculation, this comes out to be 10.9999. So what we can write here, f of which f of x5 is on the higher side and f of x6 is on the lower side, right? So it is 11.1721, this is 10.9999, right? So f of x5 is greater than f of x6, therefore eliminate, which region is to be eliminated? Eliminate the region left of x5, right? Now therefore new interval that we are going to get, is what? F of left of x5 is gone, right? So x5 is 0.5278 comma 0.7639, right? Even in this iteration we didn't get the functional values same, right? So we'll have to move ahead only, right? So let's move towards our last iteration, fourth iteration. Hopefully the values will come same. If not, we'll be stopping anyways here. So fourth iteration, right? The new interval that we had was 0.5278 5278 comma no it is 0.7639, right? So now we have the formula for, no, this is fourth iteration, so L4 dash will be 1 upon r raised to 5 into L0, so it is 1 upon 1.618 raised to 5 into 1. If you do the calculation, it comes out to be 0.0902, right? So the representation can be given as like this: 0.5278, 0.7639. It is fourth iteration, that means it is x7 and it is x8. Here we can write L4 star. This is also your L4 star, right? So the value of x7 can be given as 0.5278 plus 0.0902, and this value comes out to be 0.618. X8 can be given as 0.7639 minus, no, 0.0902. According to the calculation, it comes out to be 0.6737. F of x7 and f of x8 here, here it is coming out to be 10.9999, and here it is coming out to be 10.9610, right? So again, these two values are not same, but anyways we are going to end our, this thing after the fourth iteration only, right? So what we can do is we can find out the x star value. X star value will be the average of 0.6188 plus 0.6737 divided by 2, and therefore the value of x star will be, if you do the value, 0.6458. So this is the value of x star. We can find out the values of fx star. Putting in the equation, it comes out to be 10.7638, right? So this is after fourth iteration. Anyways, after fourth iteration we have to stop, right? So this ends your numerical.